Hello guys. So today I'll be doing some little tasks like connecting the retry engine, configuring Redis in main.go, and lastly creating a pub sub architecture so that if Redis is enabled, we will use pub sub instead of polling. In normal fallback case, we will use polling. So let me just start with the easiest part, that is connecting the retry engine to our worker pool. So currently the retry engine exposes a method which is handle failure method. Okay, so we will use this method to handle the failure in our worker. Let me go to the worker pool. What I'll do here is inside the process job, whenever a job status get failed, I will call the handle failure. It will the handle failure function on itself knows the context about whether the max retries has been done or what is the base value and all that. So we don't need to do anything like that. So let me just turn off my suggestions and start. So what I'll do is firstly j dot retry. I think we used, what do we use? Yeah, we used retry. We need j dot tool dot retry dot handle failure. It takes a context. Should have a pool dot context and a job which will be j, and that's all we need. I think pool dot retry, and then let me copy this line because we will need it here too, and lastly here too. So what it does is whenever a job fails, it will invoke the handle failure function, which internally will check if the job needs to go to red letter queue or it needs to get retried after some time. So the dead letter queue is not yet constructed, so it will be retried after some time like that. Okay, so next thing I need to do is I need to firstly add a config for Redis. We know that our queue operates in two methods, one memory method and one is Redis method. So how we will define that is using environment variables. There will be an environment variable which will be use Redis, which will be a type bool, and Redis URL, which will be a string. So what will happen is whenever we have a bool set to true, use Redis set to true, we will check Redis URL and create a new client for Redis, and based on that we will work with Redis based queue. If if use Redis is not present, then we will go to memory based queue, or if Redis URL is corrupted, we will automatically go to memory based queue. So how I'll do this is, firstly let me just define this. It's like use Redis equals to, it will be os dot, will get the env environment variable. Oh shit, whatever it is, os dot get env, and yeah, what I'll go for is use, what was this, use it will be like use Redis. Okay, so it will be something like use Redis, and I'll return if it is equal to true. So if use Redis is not present or use Redis is set to false, and this will return false and it will be stored in this variable. Next thing I need is a Redis URL, which will be os dot get env, something like Redis URL, and I don't think so I need anything else. Like it will be a string, and the environment variable provides a string, so it works fine. Let me just update the environment variables. There's nothing serious in these. So let me also turn off this for environment. Let it be. It's just a matter of seconds. I'll use underscore Redis equals to and Redis underscore URL. This the local host URL I'll be checking on, and that's all we need. Okay, so this will work. Now we need to configure it into main.go. You can see that the main.go uses new memory job, but we need a interface of a job such that based on that interface, if the job is memory job, memory store, based on memory store, it will go to memory store, and if it is based on Redis, it will go to Redis. So I'll change the second step. Instead of doing like this, I'll do something like I'll define two variables, which will be a job store and a main queue. So let me define those. Job store, which will be type of job.store, and a main queue, which will be type of queue.queue. So these are defined. So what I'll do next is I'll update this creator queue plus job store implementation. Okay, from config. That will be much better because we are creating this from config. So what we'll do is we'll check if config dot use Redis. If it is true, then what we'll do is we'll check for config dot our Redis URL, config dot Redis URL equals to. If it is empty, then we will return an error. We'll log an error. So what I'll do is, also I'm thinking instead of MMT I should use log.println, and I shouldn't rely on FFT that much. Okay, so what I'll do is I'll log error log dot fatal, because it is a fatal error. We will just describe use Redis equals to true, something like this, but Redis URL is empty. So this will log a fatal error and stop the process. As you know, the fatal just exits the process with os.exit. So next thing we need is to create a Redis options, because Redis client can be created using Redis option. It needs Redis options to be configured. For now, I'll create the Redis options based on the URL string we will get. So I'll do Redis dot parse URL. There is a function which parses the URL and converts them into options. So what I'll do is I'll just pass the URL, which is configure.redis URL. So it will create a Redis options and an error. So we'll check for error and log that. If error, what I'll do is log.fatal. It means there was invalid Redis URL. So I'll need a fatal F, something like this. So I'll do is invalid Redis URL. Should I use capital? Yes, Redis URL with the error, which is we'll use the same tree and we'll pass an error. this is it. Next I'll do is create a new Redis client. Redis dot new client. What was it? Yeah, it was Redis dot new client, and it takes option which we created above, Redis of, and what it will give us is a Redis client. So I'll do it Redis client. Which is this? So it's a type of Redis client. So I have a Redis client. Now I'll check if the Redis client is working or not. So what I'll do is ping the Redis client. So the Redis client will return error or a response. So we only care about error. So let's check about this. If error in Redis dot what is our Redis client. Now we are using the Redis client dot ping. So it will return. It needs a context, which is context dot background, because we are in the main package. So it will return us an error if anything goes wrong, or it will return us something like a result. So we only care about the error. So we will take the error and then we will check error not equal to nil. So if error is not equal to nil, what I'll do is again I'll log dot fatal lab failed to connect to Redis. Connect to Redis with %v, and error I will pass here. This is done. So after that this means we have a working Redis client. So what I'll do is I'll write a cleanup function which will run when the process is closed. So I'll write a defer function which will be a anonymous function, which will be if in Redis client dot close. So what I'll do is if we get an error, error not equal to nil, not Redis nil. So what we'll do is we'll log dot since it is not fatal, we'll just use printf. It's just cleanup function. So what I'll do is failed to close the Redis client, and the error I'll pass is %v and the error. This works fine till now, and while there's an issue must be called, something like that. Yep, now it's fixed. Next thing we need is to create a store for our jobs and a queue, which will be Redis based. Both will be Redis based. So what I'll do is create Redis store equals to job dot new Redis store. It takes Redis client. What it returns is it returns an error 2. So I'll log the error. What I'll do is if error, what I'll do is I'll log a fatal error, fatal F, failed to create Redis job store, something like that. Failed to create Redis job store with an error which is %v, and we are going to use this error. We are passed and done. We have a Redis store, and next we will create a Redis queue. And an error we will get from the function call queue dot new Redis queue will take a name. For first queue, we'll use default name. The user can override the name because we have created some methods. We just need to expose those methods using our HTTP request. But for now, our main focus is wiring Redis to this. Just like our while copy and fill to create Redis queue. This is fine. Next thing we'll do is we have a Redis store and a Redis queue. What we'll do is we'll assign that to the global variables we have created. Global variables for this function only. The main function. For the main function, we have created a local variable inside which we have created local variables for this part. So I'll assign these to them. So job store equals to a Redis store, and next thing we will do is main queue equals to Redis queue. If that is set to false, if our use Redis is set to false, what we'll do is we will override the values with memory store. Job store equals to job dot new memory store. It doesn't return any error because it's internal code, and it just uses a map. Main queue equals to queue dot new memory queue, and it needs a name. We'll do default again here. Default, and that's it. After that, we will create ID. Okay, create a default queue. Now we don't need this step. Let's remove this. We have this, and we will use, instead of this, we will use our main queue. We will register the main queue in this part. So everything will look good. Error registering queue. This will work fine. Next we need is create retry engine. What retry engine request is a queue. We'll use main queue, and in the line switch this main queue, and let me change the numbers. 5, 6, 7, 8. Here order methods a lot, so that's why I have numbered these 10, 11, and I think everything works fine. Yep, I'm done with the main function. Next thing I need to do is I'll need to create a pub subsystem. The last thing for the video will be create a pub subsystem. Instead of polling after 100 milliseconds, which our workers are doing currently, we will create a pub subsystem if the interface allows. Like in the Redis interface, we will create a pub subsystem, but in memory queue, the old fallback will be used, or in case if the pub sub fails, the old fallback will be used. So let me create a pub subsystem. So for that, what I'll do is I'll create a what can I do first? I'll have to create a function that will subscribe to the pub sub notifications. So let's create a function. It should reside in our queue, because the pub sub will be queue based. If a queue gets enqueued, the pub sub will fire and tell the workers to check if they can dequeue the job, something like that. Okay, so what I'll do is, since it's a queue interface, I'll create a notification interface type notification or notifications, whatever interface, which will be having a function. It will have a function like it should contain a function which could subscribe to notifications. Fun. subscribe func. I'm writing this spelling down. So also shouldn't use this. Subscribe notifications. So what it will take is major thing it will take is a context. Only it will take a context. Actually we have type context and it will return us three things. So what are those three things? Firstly, it will return us a read-only channel of empty struct. Empty struct because we don't care about the value. We only care about if notification gets fired. So if an event gets fired, it will be registered in this. Next, we'll create it will need a function which will be our closer function. So that the closer function, what it will do is it will unsubscribe, so it can cancel the subscription notification. So whenever our worker gets its job done and it's going to die, we will just unsubscribe the worker from this pub/sub, so that non-useful notifications won't get fired. So and it will return an error. So three things will be a empty struct channel, read-only channel, a function, and an error. Let's write the implementation. For that we'll need a Redis.go, since it will be our only place where notifications will reside. If I will write the implementation, it will be like notification subscriber function. So let's write about the notification subscriber. And one more thing we need to do is publish the notification whenever NQ happens. I'll do it later. Firstly, I'll create the subscriber function. Let me copy the interface value from here, and what I'll do is I'll create a func on our Redis-q, which will be of type Redis-q, and it will do this. It will return that, and I'll just handle this like this. And I should clean this up. This will look better. So this just defines what it returns much better. Firstly, we'll validate the context as always. So I can copy from above somewhere like this. Copy, same thing everywhere, and it will return. Second thing will be nil, since it's an error here, nil, and add. It returns three things instead of two. So once we have validated the context, we'll create a pub/sub system, which will be like this. Is how we create a pub/sub system. Redis-q dot client dot subscribe. So what we will do is what we will need here is context and channels where we need to subscribe. So for that we need an identifier for the channel, and for that I'll create a new first notifications key pub/sub notification key sub prefix, because it will be prefix, and after that we will have a tune. It will be like GoTaskQ notify, and then this is our prefix, Next we'll do is add this here, notify key, which will be a string. And next thing we need to do is, where are we creating? Yeah, here we are creating. So notify key will be like fmt.sprintf. We'll do is %s and a %s, which will be like what we'll take is notification queue. Okay, what was the name? Also pub sub notification queue. Pub sub notification queue prefix and the queue name. So it will be like notify and the queue name from where the notification comes. Okay, so this will work fine. So this is our identifier, and I'll do is here I'll just use the context we got, and the channels we want to subscribe are Redis-backed dot notify. So we need to subscribe to that channel. How can we check we are a subscriber to that channel? We will do is, if we don't care about the value, we'll just do is pubsub.receive. So receive returns a message, a subscription error, found, something like that. You can read the documentation. So it will whenever a subscription is created, it will return us some object, so we can receive that object and check if we got that, and if we got that, that's okay. If we don't got that and we got an error, we will close the pub sub and return the error. Simple as that. Let me just code this. So it will pass here is context, so it can get the context from where we are asking. Error not equal to nil. Nil, if it's not nil, it means we encountered error. We need nothing from the value. We need to close the pub sub dot close. Okay, so what it returns is, maybe we will on the right side. Oh yeah, we don't need this operator, so this will work, and I'll return nil and an error, which will be like fmg.errorf, something like subscribe queue notification field, and it will be like this %w, which will have error, and will do. Now this looks cool. If we got to this part of the code, it means we have a PubSub client, and we can get notifications. So what I'll do is create a notification object, which will be a channel. Make a channel. We need a read-only channel struct. It will be empty struct, and it can buffer a value up to 1. So we only need one notification. We can drop other notifications if multiple notifications come at the same time. We only need one to wake up our workers, and that's fine. So what I'll do is I'll create a GoFunc that will work. Like it will constantly see if there are any updates from the PubSub. So for we'll need a error. We'll check if here is PubSub dot receive message. So it will give us a message instead of giving subscription and form messages. It will just return the message or error. So we will pass the context. After passing the context, what we'll do is we'll check for error. If error nil, will return the this go function. And next thing we need is the select statement, because we are using the for select paradigm. So let's go is if we get a notification instruct this. If we get this, we will just do nothing, and the default case will be nothing. So why I wrote this is something like the default will allow it to become non-blocking, and whenever a notification occurs, whenever we get a notification, it will forward it to the notification channel, and we can get the notification from there. So it's simple as that. Lastly, we need a function and subscribe. The subscribe will be a function which will do pubsub.views. We don't care about error. It is pubsub.views. That's as much as we need. And lastly, we'll return all these values. What I'll return first is our notifications channel. And what is wrong with this post notification channel? Okay. Next, we'll return as a unsubscribe function, and lastly, we'll return nil. Okay. I think everything is done for this. So whenever Redis sends we need to publish an event. So for that, we need to do something like whenever we enqueue a job, we'll publish an event. Here we are enqueuing a job. So lastly, we'll do is pipe dot publish. So I'll publish the channel, which will be publish the notification, which will be Redis-backed dot retry key. Notify key. And lastly, we'll need a message. It will be member. The member is our member for job. The message does not matter. We can send anything as long as this works, because we don't care about the message here. As you can see, we only care about if notification occurs. So I think here my work is done. Next thing I need to do is I need to integrate this into our system. The system I created is here. So what I'll do here is inside run worker, firstly I'll check if the interface has a method for notifications. So how I will check this is by using typecasting. So stick and see what I'll do. I just learned this concept today, so I can be something like wrong, but I liked it, so that's why I'm using it here. So I create a notification channel which will be an empty channel struct. So it will be an empty channel struct and empty read only channel struct. Next value we will need is a unsubscribe function. I'm writing this so that even if the queue does not have these methods, our implementation does not break. Okay, so let me write these methods like I should write it func, which will be an empty function. Okay. Next thing I need to do is the pattern I am talking about, which is I'll use the pattern of typecasting. So I'll check if there is a notifier in our interface. Notifier, okay. If there is a notifier, then it will return okay. If there is not, it will not return okay. So what I'll do is pool.q dot, I'll check for the type q dot notifications. If it has a method for this type, it will return okay, and I'll check if it is okay. Then I'll get the channel from a cancel function, which will unsubscribe function from our notifier dot subscribe notification, and it will need a it will need a context, and it will be pool dot context. And I think it was next thing we need to do is yeah, it also returns an error. We'll check for error. If there is an error, we'll log the error. Log.printf. What I'll log here is worker with ID. Worker will provide the ID, which is from 0 to something like pool.numWorkers, which we created when we were creating the worker pool. Q notifications. Q notifications is right there. Notification. Subscribe. Something like this. And the error we get is %3. I'll just forward these two. The ID will be our ID, and the error will be our type. So it will check if we get any error. If no, then we will do is then we will set the default values to this. So should we notify channel will be set to the channel type, and our cancel function will be set to our unsubscribe function will be set to our cancel function. So now we have two global scope for them, and after that I'll defer unsubscribe. So whenever a pool gets closed, whenever a worker stops, first it will unsubscribe, then it will go to this, because defer works in stack wise. So this will be at the top of stack, and this will be at the bottom of stack. First it will execute, then it will execute. Okay, so now let's go for the select. In select statement, we don't need to change this. We just need to change some things. Like here I'm using job, which can create some issues. Like give me a sec, I have to go somewhere. I'll come in about 2 minutes. हाँ जी भैया आ गया. Sorry for the delay. I had to go get the delivery for my food. Now let's continue. Where was I? I was changing the name of job because this can be confusing with the package name. So I'll just name this DQ job as it is being DQ, and I'll change this to DQ job. This only has the scope inside this, so I think I've changed everything. And it is DQ job dot ID, and that's fine. Next thing I need is I'll check if error equals to nil is not equals to nil. It means we have a if not, we'll check for notification channel. If error is not equals to nil, if there is an error, we will check for notification channel. So what I'll do is if notified channel not equals to nil, if there's something in the notified channel, then I'll use the select statement once more inside, which will be like select. The case will be our reading from tool.context.done, and if it's there, will be done immediately from this select statement. And next case will be like if we get a notification from our notification channel, we'll do anything, which is what we need, and we'll need a case. We will obviously check if if sometimes notification channel does not fire, we will always check for 100 millisecond fallback, which will be like time dot sleep, whichever comes first. Time dot after, sorry, here we will do time dot after because we don't want it to be blocking. 100 into time dot millisecond, and that's it. And what I'll do here is have a continue statement after this, so it will continue for other jobs as well after this. The time dot sleep, this and this. This is our fallback method. If notification channel is not nil, it means we have a notification channel. We will use this method. If notification channel is nil, we will directly fall back to this method. So this works, and I think I'm done with majorly integrating the tool. There's one error where there's the error I didn't initiate it, so I think it's done. What we'll do is check everything. It looks good to me. So thanks for joining. Okay, bye. I'll continue tomorrow. I'll do two things majorly. First will be the DLQ implementation, which will be our dead letter queue implementation, and maybe I'll expose some more of our HTTP methods. And lastly, one thing I need to do is use metrics which will be provided by Prometheus. So let's see how far it goes. Tomorrow maybe I'll complete dead letter queue and some HTTP requests, and day after tomorrow Prometheus, I'll be done with Prometheus, and the project will be completed day after tomorrow, I guess. Okay, thanks for